You're live. Okay, so today, objective. We're looking at quadratic models. Okay, what the heck does that mean? Okay, so quadratic models, what the heck? Oh, don't you love all this math lingo? That's why I still have a job, because I know what it means, right? So quadratics, those are our x squares, right? So those are our parabolas. And models is going to be like a real world scatterplot type. So a real world with a scatterplot, okay? Okay, I am a track coach, so here we go. Coach Davies has 6 different people that run the 400 meters, and the results, here's their time and their age. So if a 10-year-old, a 13-year-old, 15-year-old, 22-year-old, a 30-year-old, a 41-year-old, and a 50. Now these are in seconds, okay? So these are the times. So I threw a 10-year-old on the track and said, go, right? So the 10-year-old went around the track and did it in 123 seconds, right? About 2 minutes. We got all the way down to the 22-year-old, and they ran about a 50-55, which is not bad, right? Not as fast as Jace, but you know, Jace is actually a state runner. So let's go ahead and,
Jace ran to Utah.
I know, doggone it. He's going to clean up in Utah. So let's go just do a scatter plot, okay? So I do a scatter plot of my data. All right, and I'm going to go probably, let's see, 10, 20, 30, 40, 50, 60, 70. What if we went by 5s? 10, 20, 30, 40, 50, 60. I'm going to do that. I'm going to go by 5s. 10, 20, 30, 40, 50, and 60. Yeah, you bet, Seth. Okay, so I just went, and this is my age, right? And then I'm going to do my times in terms of seconds, okay? My lowest time is 55, so I'm going to do a squishy. Remember how I do my little squishy? Do a squishy accordion graph. So I'm going to start at, say, 50 seconds. So I'll let this be 50, 60, 70, 80, 90, 100. What if I went by 10? 50, 60, 70, 80, 90, 100, 110, 120. Yeah, I'm going to go by 5. So it goes 60, 70, this is in terms of seconds. 70, I'm going to go 80, 90, 100, 120 seconds, 130 seconds, and that's as high as we need to go, okay? So I like to do my little accordion squishy because everything from 50 below, there's no time, so we just squish that part of the graph away, right? You guys agree? It just helps me, gives me a better look at the graph, okay? So now, make a scatter plot. I'm going to do that. So at 10, I'm at 123 seconds. Maybe that's about there. 13, I'm going to have a time of about 105. Right about there. Okay. 15-year-old is going to do it at 68. Yeah, I should look like a parabola, hopefully. 68, a whole bunch of parabola. 22-year-old is going to be at 55. 30-year-old is going to be 61. 41-year-old is going to be 70.
Mr. Davies.
Am I off?
I think you are missing 110.
Oh, I am missing 110. 120. Yes, and 130. Thanks, you guys. Me make a mistake? Never. It never happens, right? So that's why I have 3 bottles of whiteout. Thank you, John. 10, 123, 123 is there, right? And then 13 is 105. Okay, I'm better. I'm back on track, I think, right? Okay, 41 is at 70. And 55 is at about 130, okay? Okay, there it is. Now, if I were, and don't do this, I don't want you to draw this, I'm going to draw this in pencil, okay? So it looks like it really could be, and I'm going to draw it in, right? It could maybe be a parabola, right? Okay, just watch. So I don't want you to draw this, just let me draw it, okay? So if I draw my parabola, there's no way it's going to get all these points. You guys agree? It's going to miss some. So my R value, remember the R? My R value is not going to be 1. Okay, it might be 0.9 something, but it's not going to be 1 because that graph can't hit all these points, right? But it still looks to me like it's a parabola. I think that's the best fit. There's no way it's a straight line. So if I had to pick between 1 linear or 2 quadratic, it's definitely quadratic, right? And we all know that, at a certain age you can run your fastest time, and as you get older it slows down, right? If you're a little kid and you're baby and you're crawling across the track, it's going to be pretty slow. So we do know it has to be a parabola, right? So again, Isaac's way ahead of me. Isaac, what are you doing? You're putting in the calculator, right? So let's go to our stat button. And let's enter our data. And then we're going to find our quad reg, right? So let's see if I do this on clear, stat, edit, clear my list, and I'm going to go 10, 13, 15, 22, 30, 41, and 55, right? List 2, 123, 105, 68, 55, 61, 70, and 130. Okay, how am I doing? Am I going too fast? Am I okay? Are we okay? Okay. So then I got to go back to my stat, calculate, right? Okay, I'll wait for you. Okay. Yeah. So we need the equation. That's a great question.
So what, we need to plug in an age for an x, yeah?
Or we'll use our negative b over 2a, because that would be the vertex, right?
Which is just the 22-year-old.
You might run it faster at a different age. You might run it faster when you're 19, right?
What would be the fastest age?
Right. Okay, so then we go to calculate, go back to stat, go down to over to calculate. Now we're going to do our quadratic reg, right? Quad reg, because we believe it's quadratic, right? Everybody agree? Quadratic. Okay, down to calculate, and here it is. Okay, so my r squared value, that's not great, but it's not bad. So if I round this a little bit to 0.14, so I'm going to say that a is 0.14, b is, I got a negative 8.6, and c is about 186. Okay, so my equation then would be y equals 0.14x squared minus 8.6x plus 186. Okay, that's my equation, right? Where x is age and y is time. So I could change it to t of a if I wanted to get fancy, because I like to get fancy, because what does this thing have to do with time over age, right? I could change it to 0.14a squared minus 8.6a plus 186. I like that better. That's a better, because it means something, age and time, right? It means something, okay? So, we've got that. There's my quadratic model. There it is right there. I'm happy with that. Okay, now, what could be the fastest time and at what age? So, the fastest time, according to what I drew in, would be somewhere around here, okay? Somewhere around here. Maybe it's age 29, maybe it's age 25, but we can guess because that's the vertex. Isn't that the vertex? So that's my vertex. And if I need to find the vertex, then I have a little equation, right? I've got that negative b over 2a. So I'm going to say, okay, that a for age is equal to negative b over 2a. Okay, because I want to find the x value of the vertex, which would be the age. Okay, so I'm going to do my negative b over 2a. So I'm going to go, okay, I'm going to go negative 8.6 divided by 2 times 0.14. Okay, there's my a, negative b, there's my b, negative b over 2a. Okay, so I'm just going to use my calculator. I'm going to go ahead and do this. That's 8.6 divided by 2.8.28, right? Just simplify that. Okay with that. So what is 8.6 divided by 0.28, and I get an age of about 30.7, okay? So we can round that up to about 31 years old, okay? 30.7 as my age, okay? That means what? 30 years and almost half a year, right? Okay? Depending on when you're born. Right? Sometime in July. That kind of makes sense. There we go. So, now, that's the age. How fast would the kid go? How fast would this superstar go? How could we find the time? Plug it in, right? So if we plug it in, let's take our 30.7 and plug it in, right? We'll plug it in for A here, and we'll plug it in for A here into my quadratic model, my equation, right? So I'm going to go, okay, T of 30.7 equals, all right, 0.14 times 30.7 squared minus 8.6 times 30.7 plus 186, right? Okay, so I plugged it in, and definitely going to use my calculator. You guys agree? Definitely use my calculator, because otherwise I'm not going to be able to do that. I have to use my calculator. Cannot do that in my head. I'm not that smart, even though you think I am some days, huh? You know, it's not true. Subtract 8.6 parentheses 30.7 plus 186. I get an answer of about 53.9 seconds. That's not bad. 400. That's pretty good. Isaac, that wouldn't be a bad time, would it? Okay.
Wait, for what?
For the 400?
Oh, no.
That's a good time. Right? It's not world class, but it's not bad. Okay. All right. Thumbs up. Thumbs up. Okay. All right. So we still have